Hey y'all, and welcome back to Coding with Minmer. On today's agenda, we're going to tackle Leetcode problem 1047, remove all adjacent duplicates in a string. After that, we'll go over an actual variant of the original question that Meta asks. The variant is asked the majority of the time, and as you'll see, there's a slight wording change in the problem statement that completely changes the implementation. We'll make sure to make it real clear. But without further ado, let's dive into the problem statement. Okay, so we're given a string S consisting of only lowercase English letters. We want to make as many duplicate removals in this string until we no longer can. The problem defines a duplicate removal as picking any two characters right next to each other and are the same letter and removing them from the string. We'll return the final string after all such duplicate removals. The intuitive solution is to try to simulate exactly this. We can iterate left to right in a for loop, and for each character, look back to see if we have an adjacent duplicate. If we do, we can simply remove the pair. Okay, so going through this very example, on the first iteration, we have an A. There's nothing before this character at all. It's our very first one, which means for all we know, there is no duplicate removal for the A. We'll keep it in the string for now. Moving on to the B, we actually have a character before to compare now. However, B is not equal to A, so we do not remove anything. We move on, and on the next iteration, however, we have another B, and what do you know? We have an adjacent B right next to it. Since the two are equal, we meet the criteria for a duplicate removal, and we can remove both B's. We can use the erase function in C++, or something similar in other languages. Great, let's move on. We now have an A. When we look back not at the B because it was a duplicate removed, but instead we look back at the rightful previous character, the A. They are technically next to each other and they are equal, so let's remove them both. On the next iteration, we have a Z. There's no character before it, so we'll keep it around for now, but we'll remove it in the case that we encounter an adjacent Z. As you can see in the rest of the string, we won't, but that's the train of thought at least. After this iteration, we have a C that does not equal the Z, so we do not qualify for a duplicate removal. We keep it around. After that, however, we do have an adjacent duplicate. C is equal to C. We'll remove both C's. It's interesting that after this, we have a third C, but we don't actually remove it. Remember, a duplicate removal is defined as picking two and only two characters to remove, not three, or four, or five for that matter, and so forth. But anyway, C does not equal to the Z before. We retain the C and move on to the final iteration where we have a Y. Y is also not equal to C. There's nothing to delete. We include it in our resulting string of Z, C, Y. Now, among other reasons why this solution is sketchy, the time complexity is also very inefficient. Recall how we got rid of duplicate characters. We called the erase function, which is a big O of n operation. And that inside of a left to right for loop would yield a time complexity of n squared. How can we do better? Let's rewind our example and see what we can do. We'll still loop left to right through every character, but anytime we encounter a character we want to keep, like this A right here and this B in the first and second iterations respectively, remember, we simply push it to another string. And sure, why not? Let's just call it string for now, and it has the A and B that we push. We do this because when we do encounter a character we want to remove, like this second B right here, then we can call the pop function on this B in our extra string in big O1 time complexity. Let's get rid of that. And we'll also skip pushing this B, the second B, into our string, thereby moving on to the next iteration. If we do these two things, we successfully avoid calling the nested big O(n) erase function call. This external string, then, represents an intermediate space where we'll slowly build our resulting string, keeping characters so long as we don't have to duplicate remove them, and oppositely removing them how we just did whenever we do have to duplicate remove them. Therefore, we realize two things. One, we should name this string something like result, since that just makes more sense. It represents our eventual answer string and will eventually return it at the end of our function. And 2, on any given iteration of our for loop, like this one, this is where we currently are, we'll compare the current character with the previous character in our resulting string so far, not the actual input string. Because if we did, we'd mistakenly compare the A with the B, a B that we had duplicate removed in the iteration before. Let's X out the two B's up here to visually display that. No, we didn't actually erase them from our string. I'm just showing that so we know that we no longer consider them as part of our answer. So yes, the takeaway is that we compare the current character with the previous one in our result. Okay, let's finish this walkthrough. As we saw, we compare the current letter A with the previous character in our result so far, and lucky here, they're both equal and next to each other. Let's pop the A and skip adding this A into our result. Let's X them out just to show it visually. On the next iteration, we have a Z. There's no longer any previous characters before it. We know this because result is empty. So in these cases, we'll just simply push the Z into our answer. And if you want to visually verify in the OG string, yep, there's nothing before the Z. You kind of get the idea of the workflow now. Next up, we have a C. We follow the same procedure. It's next to the Z, but do they equal each other? No, they don't. Thus, let's just add it to our string with a C. After that, we have another C. This time it does equal the character before. Let's pop from the back of our result and simply continue on to the next iteration. I'm going to X these guys out. Now we have the third C. We compare it with the character before. Nope, there's no need for a duplicate removal at all. We'll push it to our result. On the final iteration, we have a Y. Comparing it, the two do not equal. No duplicate removal at all. We'll push it to our answer. So to summarize what we do, when there's no previous character or the current character doesn't equal the previous character, then we'll simply push the character to our string. Otherwise, we must have a duplicate removal. In those cases, we'll just pop and skip to the next iteration. Ultimately, the resulting string we return is the same as before in the brute force solution, Z, C, Y. But this time, the time complexity has been improved to big O(n). The space complexity is big O1 constant space, unless of course you want to count the result as an auxiliary space variable. The code is funnily not even 10 lines of code. Let's speedrun it. Before we can start iterating through each character, we need a result variable, to which we'll be building our answer. We'll ultimately return it at the end of our function. Okay, now we can enter our for loop, where we'll go through each character. What are the two cases we simply push the current character to our result? It's when our result is empty, or when the character doesn't equal the previous character in our result. We'll just push it like so. Otherwise, there must have been an adjacent duplicate. Let's pop a character from our string and do nothing else to move on to the next iteration. It's the pop and skip. Okay, and that is it. With that said, let's get into the variant. Meta rarely asks the original LeetCode problem. They more likely ask this variant, that now, given a string still consisting of lowercase English letters, we want to return the final string after we remove all, and that's the key word here, all, duplicate letters. Take a look at our example here. In the previous problem, we did what was called a duplicate removal, where we picked two of the same characters next to each other, such as these two B's, and got rid of them from our string. And to do that, remember we did the classic pop and skip. If we tried this algorithm in this variant, it wouldn't work because you would have missed removing this third B. As to why this happens, it's because the moment we iterated to the second B, we look back, realize there's an adjacent duplicate, and we immediately remove them. When really, we should have waited until we iterated to the first non-B, namely this A right here, to then look back at the chain of B's and remove all three of them, not just the two. Okay, let's modify our previous solution with this idea in mind and go through a quick walkthrough. On the first iteration, we have an A, and because there's no character before it, we'll push it to our result so far. Let's call it letters this time, however, because why not? It's still descriptive. It will first contain the A. Next, we have a B. A and B, however, are not duplicates, so we simply push the B into our string. After that, we have the second b, which we will now also push to our letters string. We hold our tongue and do not pop like we did in the previous solution. We'll do the very same thing with the third b. Be patient, don't remove anything, we'd rather push. Finally, it's not until we get to this a that we look back in our string and check if there's more than one b or not. Clearly, there's 3. So what do? We obviously want to remove all of them. Do we call the pop function on each of the 3? I mean, we can, but that's very inefficient. Hypothetically, we could have hundreds or even thousands of b's. I'd very much rather pop the b's all in one pop function. But how? To optimize, we can change how we model our data structure here, our string, and instead abstract each group of letters into an object of 2 fields. One, the value of the character, as well as the frequency. So for a string like this, we have an a that occurs 1 time, a frequency of 1, and a value of b that occurs 3 times. So again, a b that happens 3 times in a row. This is an object, and this is an object. Of course, it's still called letters. Let's abandon the old data type now. We'd rather opt for this vector of letters rather than the string. But with this new schema, let's continue where we left off in our loop with the a. We can now look back in our letters and ask the question, does the previous character occur more than 1 time? Yes, indeed, the b shows up 3 times. And indeed, if you want to check with the OG string, here are those 3 b's. What we'll do is call the pop function of the b's in one go. That's perfect. Let's also, like before, visually display the xing up here. We don't actually erase these in the actual input string. I'm just doing it so we can follow along a bit easier. Okay, but we're not done with this iteration just yet. What do we now do with this newfound a? Well, I'll tell you what we don't do. We do not just push it to our vector of letters and push an a with a frequency of 1. And that's because by popping the previous chain of b's, we revealed a duplicate a. And looking at our original input string, that is indeed the case. The right thing to do is to have an if statement for this and actually increment the frequency to 2 to represent these 2 consecutive a's. Now we're done with the iteration. Next up, we have a c letter. Does the previous character occur more than once and thus have duplicates? Yes, indeed, the a occurs 2 times in a row. Again, here they are. Like we did before, we'll pop the a object, and let's also show that here. And this time, it unveiled literally nothing. Our vector of letters is empty. There's nothing before this c, also as seen here in the input string. So in this case, we'll push the c with a default frequency of 1, since it's occurred 1 time so far. Next iteration, we have an x letter. We look back. Do we pop the previous character? Nope, the c only occurred 1 time. There aren't any duplicate c's beside it. Now, what do we decide to do with the x? We compare it with the previous character. It's not equal to the c, so let's push x with a frequency of 1. Next up, we have a d. We ask the question, do we pop the x? No, because it's only occurred 1 time. As for the d itself, we compare it with the previous character. They do not equal each other. Let's add it to our vector of letters. On the last iteration, we repeat the logic. Do we pop the d before? No, we don't. Then, in regards to our current character, d, it's equal to the character before, also a d. Let's increment its frequency. And we're done. We have a final result of c, x, and 2 d's. But hold on, we didn't remove the last 2 d's. Looking at our input string for reference, they're clearly duplicates and they're right next to each other. What gives? Well, we realized we only ever removed duplicates once we encountered a different character afterwards. For example, we popped these b's only when we got to the first non-b, this a. Similarly, we popped these 2 a's when we got to the first non-a, this c. For the d, however, there's literally nothing after to signal to us that we must check for duplicate letters. This just means we need yet another if statement after our for loop that if our vector of letters is not empty and the most recent character occurs more than 1 time, here it's 2, and thus there are duplicates, we'll do one last manual pop. Rewriting our result here, we have a single C and then a single X. Let's write that out. And that is our answer. But recall, we wanted to return a string type in our function, not a vector of letter objects. So the final question is, how do we make the transformation from here to here? Well, it's quite simple. We can just iterate through our letters vector and push each letter once to our final result. We are very confident that when we do loop through these characters, that each letter in our vector only occurs one time. Because if a character occurs more than once in a row, our algorithm gets rid of them, such as this A, this B, and this D. That was the whole goal of our algorithm. Ultimately, we have an answer of CX, and that's what we return. Our time complexity is big O(n). Because though we had a lot of for loops, they were all siblings to one another, nothing was nested. Our space complexity is big O(n) this time because of our vector of letters, as well as our result string here that we return, which is technically auxiliary space. I realize there are many if statements in the logic, but don't worry, I'll go over an example as we code up the solution. With that said, let's get started. Okay, so like I said, for this code example, we'll be going through this example, the same one as before, and slowly build out the code. The first thing we'll do is actually demolish the old code. It will look nothing like our variant. Next up, note here that I have our vector of letters already prepared. That's the data structure of choice instead of a string. Let's code that up. It's going to be a struct called letter, just like we named it, and it'll contain two fields. It's the value, which is the letter, and its frequency as an int. Let's now initialize that vector of letters that we'll use. Let's call it letters. And now let's iterate through every single character of our string and see what we have to do. On the first iteration, we have an A. Our vector is empty, and if there is nothing before the A, let's just push that into our vector of letters of the A and a default frequency of 1. And after that, we'll move on to the next iteration. Coding that up, if our letters vector is empty, then we'll push it into our letters with the character and a frequency of 1. That's all we'll do in those cases. We move on. On the next iteration, we have a B. I'll remind you that early on in any of our iterations, we check if we need to pop the previous character, and we only do if the frequency is greater than 1. Here, that's not the case, so we don't do anything with that. Let's have that check real quick, that if the previous character and its frequency exceeds 1, then it's a duplicate. There could be 2 or even 100 of them. We'll pop it all in one function call. We're not done with this B on this iteration just yet. We got to figure out what to do with it. We'll compare it with the previous character, this A right here, realize they are not equal, so therefore we'll just push the B to our vector with a frequency of 1. This logic comes after the previous if statement. We get rid of any duplicates beforehand, and after that we'll take care of the character itself. That if the most previous character, the A, is not equal to the current B, then we'll push that B back with a frequency of 1. On the next iteration, we have a B. If we compare it with the previous character, we'll note they are equal to one another. Therefore, in this case, we'll just increment the frequency to 2. We'll actually put this if statement before this piece of code, because in the case where the two characters are the same, we know for sure we're not going to actually pop anything. We only pop when we find the next non-B, which in this case is this A. Concretely in the code, we'll put that if statement on line 14, where if the previous character's value is equal to the current character, they're both B's in this example, then we'll simply increment its frequency and continue on to the next iteration. We're done with this B, and now we're moving on to the third B. We'll execute the same block of code right here and simply increment the frequency to 3. There are 3 B's in a row. After that, we're at an A. Nope, our letters vector is not empty, and no, it doesn't equal the B before. Now we move on to the line 19. Does the character before occur more than once? Indeed, the B occurs 3 times. What do? We're gonna pop in one go, like so. We can visually denote it here as well. As a side effect, popping the B's revealed this A, which because the two are the same, we're gonna increment its frequency to 2. Following the logic in code, this happens after line 19 of any popping. If it unveiled that the previous character is a character that equals our current one, like the A that we just saw, we will increment its frequency. On the next iteration, we have a C. What do? Let's look at the code. Is our vector empty? Nope, it's not. Is it equal to the character before? No, because C is not equal to the A. Do we pop the previous character at all? Yes, indeed, the A occurs 2 times. Let's pop it as appropriate. And remember, let's just cutely mark it up here. This time, however, popping the A revealed literally nothing. Our vectors is empty right now. So this is yet another case. In this case, we're just going to push the C with a frequency of 1. To accommodate for that, we can stuff that check right here on line 22. That we push with a frequency of 1 in the case where our vector is empty, or if there is a character, the C is not equal to anything before. Moving on, we now have an X. Let's go through the gauntlet of if checkments real quick. Our vectors is not empty. It is not equal to C. The C only occurs once, so we don't pop anything. The X, however, does not equal that C, so we push the X with a frequency of 1. On the next iteration, we go through the same exact logic and add the D with a frequency of 1. And on the last iteration, sure, let's go through the if statements for fun. Our vector is not empty, but the D is equal to a character before. We'll increment its frequency and continue to the next iteration. Again, there's no need to pop anything if the two equal and we just increment its frequency. Let's do that here to 2, and we're done with the for loop. After the for loop, though, remember, we have an if statement to check if the previous letter in our vector occurs more than once, in which case it's a duplicate. If that's the case, we will remove the 2. We'll pop the D. Specifically in code, if our vector is not empty, then we can make the check that if the most recent character exceeds a frequency of 1, well, it must also be a duplicate. Let's remove it. After this, the very last thing we'll do is transform our vector into a string called result. We're going to iterate through the vector and add first the C and then the X. Let's display that here, C and the X. That is our answer. Deciphering that into code, we have a string variable called result that we will return. But before doing so, we're going to loop over our vector. We have the value and the frequency. We're not going to use the frequency because we're guaranteed that it happens one time if it's still in the vector. Let's simply add the value, the character, to the result. Get rid of these braces for compactness, and there you have it. Of course, it goes without saying that this code is way more demanding than the original LeetCode problem. And another note, yes, you can tidy this code up, but if you can on the spot come up with a better solution in a 15-minute interview, all the power to you. I'm just coming up with the first intuitive answer I can think of. Alright, I hope that made sense. Good luck on your interviews. And if you learned something today, please make sure you like, comment, and subscribe. Thanks for watching.